This is day 2 of chapter 4 section 2 on integer exponents. This is just a review right here that any base with a negative exponent will be 1 over that base and its exponent, except when b or the base cannot equal 0. And any base to the 0 power will equal 1, but again b cannot equal 0 or the base. Some quick stuff. Just a basic reminder, 10 to the negative 6 power. We want to change these to fractions. This part's pretty easy. Sometimes that'll be the assignment right there at hand. Then you may have to simplify it. If that's the case, then that's going to take a little bit more work. You're going to have to sit there and write multiple 10s. I'm going to have to stretch this out a little bit. There we go. And the reminder when you're looking at base 10 is that the exponent is just telling you how many zeros are right. So in this case, we don't really need to multiply all these things. All we need to really do is count out zeros. 1, 2, 3, 4, 5, 6. And there's your 1. And you're done. Base 10 is relatively easy as long as you remember how the exponent has its relationship with the 0. When it comes to numbers that aren't base 10, it takes a little bit more effort on your part. The quantity negative 4 to the negative square. So that means we're going to have to write 1 over exactly what we see, which is the quantity of negative 4, but now to a positive square. We're going to want to expand that to the quantity of negative 4 times the quantity of negative 4. Your negative positive rules will tell you that negative 4 times negative 4 is positive 16. Five to the negative cube, well, that's 1 over 5 cubed. That'll now be 1 over 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. Now let's solve a simpler expression. 9 minus 4 to the 0 power plus 5 to the negative square. There are no parentheses, so we can work from left to right in terms of the rest of the order of operations. So we look for any exponents. There's 1. So 4 to the 0 power is 1. Here's another. This will be 1 over 5 squared. Now this is a grouping symbol, but we enter exponents down here, so we're going to work on that. 9 minus 1 plus, and let's just do 5 times 5 in our head right now. And that's going to be 1/25. Working from left to right, because subtraction can be solved before addition. 9 minus 1 is 8. 8 plus 1/25 is, well, 8 and 1/25. Now here's another example we need to cover for today. It would have been nice to have done it yesterday, but we are limited with how much time we can put in these videos. So, the quantity 4w to the negative square plus w to the negative first power for w is equal to 3. So we're going to substitute 3 for w wherever we see it. So 4 times 3 to the negative square plus 3 to the negative first. Order of operations, 4 times 3 is first, which is 12, to the negative square, plus 3 to the negative first. So now we're going to do this. We're going to change this negative exponent to a positive, so that's going to be 1 over 12 squared plus 1 over 3. This is the one we have. This is already simplified for us, so that's terrific. 12 squared is 1 over 12 times 12 plus 1/3. 12 times 12 is 144. Now we can only add fractions when they're like fractions. So we need to come up with an LCD of 144 and 3. Well, I hope you remember how to do this. This is called prime factorization. 144 is 12 times 12, but 12 and 12 are not primes. 12 is 3 times 2 times 2, that's 12. And now I'm going to write another 12. 3 times 2 times 2. This denominator is 3, so it's just a prime 3. This right here is our GCF. So our least common denominator is going to be this number multiplied with all of these other numbers. So I'm going to put this 3 next to this, and then all those 2's. So that's 9, that's 4, that's 4. That's 36. Alright, 36 times 4. 6 times 4 is 24. I'm going to carry a 2. 4 times 3 is 12. Right? Plus 2 is 14. So the question is, what do we multiply 3 with to get 144? Well, actually, that answer is right up here for you. The fraction that we're going to multiply 1/3 with, well, is right here. This denominator of 3 is represented right here. So everything that's not part of that denominator is right here for us, and we can use this. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 3, okay, 16 times 3 is 48. So now you have 144, excuse me, plus 48 over, and we know that 3 times 48 is going to give us 144. We'll double check that right here. 8 times 3 is 24. 3 times 4 is 12, plus 2 is 14. So now we can add these together since they're like fractions. So that's going to be 1 plus 48 is 49 over 144. Now you might be wondering, can you simplify this? Well, that's why we do prime factorization. 49 is a square number. It's 7 times 7. And we've already done the prime factorization for 144. And the question I'll ask you as I write it out is, are there any factors of 7 in the prime factorization of 144? Now if you don't see any 7's here, that means they don't share a common factor of 7. And you know what? We'll ask the same thing going up. Do you see any factors of 3 or 2 in 49? The answer to both of those questions is no. So, despite the fact that it might look like a fraction you can simplify, 49 over 144 is our final answer. that's just about the whole problem right there, I believe. Hopefully this helps you out. Again, take time with the video if you need to. Watch it on your own and use it to your helpful benefit, alright? Good luck, everybody.